Hello, Accelerated Math 7-8 students. We are still in Module 10. We are finishing up our last few lessons. The lesson that we're going to be working on today is called the scale factor as a percent for a scale drawing. And we find that on page 63 in my copbook. So here we go. The scale factor as a percent for a scale drawing. So very quickly, just as a quick reminder, because it's been a long time, like the end of last year, when we talked about scale drawings with scale factors, and just a reminder, we used to call it something that looks like this, okay? I hope this helps you remember that y is the dependent, okay, and x is the independent, and m was your rate, also known as your constant, right? Also known as, this might be unit rate, sorry, unit rate, constant, rate of change, anything that constantly happens to the x that gives you the y. So the reason why I'm doing this quick reminder is, read the title again with me, the scale factor as a percent for a scale drawing, okay? So scale factor is also what the m was. It was known as the scale factor with our drawings, okay? So in today's lesson, this scale factor is going to come in the form of a percent, okay? So our goal for today we will make scale drawings with the scale factor that is a percent. The question that I want you to be thinking about is, can you have two different scale factors in the same drawing? And then things to remember. And like I said earlier, this is a way back remembering. So things to remember. Scale drawing, a drawing of an actual thing using a scale factor. A reduction is a scale drawing that is smaller than the original. An enlargement is a scale drawing that is larger than the original. A scale factor is a rate multiplied by the dimensions to create a drawing of the original. And then I have this. Okay, and this is going way, 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 way back. We talked about an equation that was scale drawing equals scale factor times the original. So we have SD equals R times O. SD standing for scale drawing, R standing for scale factor, and O standing for the original. So I'm hoping that this is ringing a bell to all of you guys. So a way to test to see if you remember it is we have a snowman scale drawing. Now, this doesn't look like a snowman at all, okay? But we're going to turn it into a snowman by the time we're done. So we have the original is this size, figure A is this size, and figure B is this size. And what I want you to notice about these pictures is, yes, they're all octagons, okay? Second thing is they have different side lengths. So this is 4, whereas this is 3. They are not drawn to scale. They are not drawn to scale at all. This is 2, and this is 1.5, and this is 6, and this is 4.5. So those are the lengths, okay? Now, what we're going to try to do is we're going to try to figure out which parts they are. So if this is the original, what you think that piece is. If this is figure A, what kind of scale drawing is and what piece it would be. And then figure B would be what kind of figure it is and what part it is for our snowman, because these 3 parts are going to make a snowman. So another thing that I want to think about right here is what is or are the scale factors. Okay, so you're going to use this formula right here. Scale drawing equals scale factor of the original. Now, something that you have been working on as a group is if you're missing information, that's what you find. So let's look at it. We have scale drawing equals scale factor times the original, okay? And so what we have to look at, this is the original. So we're going to use corresponding parts to figure it out. So if this is the top part of the original, we're going to say the 4 goes right here. If this is the top part of figure A, then figure A is the scale drawing. So what are we missing? We don't know what the scale factor is. So we're trying to figure out the scale factor. And not only are we trying to figure out the scale factor, but we're trying to figure it out as a percent. So again, I'm going to write this formula, quantity equals percent times whole. Do you see how we are correlating it with everything? It keeps coming back. You think you're done, but you're not, because it's still here. So the whole has to be 4. The percent, we don't know. so we can stick with R if you want, just so that we keep consistency. And then the quantity is 2. So our job is to figure out what it is. So you can do it one of two ways. You can do the double number line, knowing that 100% equals 4, and your job is to figure out what 2 is. So you ask yourself, how did I get from 4 to 2? Well, I divided that by 2, so what you do to one side, you have to do to the other, so this would be 50%. So we now know that this section of the snowman would be considered half of the whole, okay? Half of the whole. So that's what we're looking at right here. So in this problem, we know the percent was 50%. So 50% of 4 gives us 2. Well, now let's check and see the other corresponding parts and see if they work. So again, the whole this time was 3. The percent, we don't know, but the quantity was 1.5. So again, if you're drawing your double number line, you know that the whole is 100%, and this time it happens to be 3, and the part is 1.5. So you ask yourself, how did you get from 3 to 1.5? Oh, well, I divided it by 2. Divide by 2, so I get 50%. So we know the scale factor for this one was 50% as well. Okay, so the scale factor of going from the original to figure A is 50%. Okay, does everybody see that? So scale factor from going from the original to the scale drawing, which is figure A, right, is 50%. Okay, that's what we've learned. Okay, so now we have to test the other one. We're going to go this time from the original to figure B. Okay, so again, we take corresponding parts. So the original on this one, so quantity equals percent times whole. We're still using it. The whole is still 4. The percent is unknown, and the quantity this time is 6. Okay, well, we can do that. Our our double number line is going to look a bit different, however, because 100% is right here, and that's 4, and 6 is over here. So you can either keep going on the double number line like that, or you can use the BU chart. I kind of want to use the BU chart, so I have B and U. My variable is R. What did I do to R? I multiplied by 4, so I have to divide by 4, and that should give me R. Okay, so I'm going to divide this by 4, so I'm left with R on this side, because 4 divided by 4 is 1. 1 times R is R. What you do to one side, you have to do to the other, so that's really 3 halves. And the same thing of 3 halves is 1.5. So now I know that to get from 4 to 6, I multiplied it by 1.5. So now all I have to do is times 1.5 by 100 to figure out the percent. And so I get 0, 0, 5, 1 place over. So now I know the percent to get a 6 is 150. Okay? So 150%, so R equals 150%. So now let's try the other corresponding length. So again, we have quantity equals percent times whole, and this time we have 3 times, we don't know, equals 4.5. So let's see what that shows us. Okay, so again, if we use the double number line, this time we know that 100% is 3, and the next one we need to get to is 4.5. So we have to figure out how we got there. So again, BU chart, variables are multiplied by 3, so I have to divide by 3. That gives me R. So I'm going to divide this side by 3. 3 divided by 3 is 1. 1 times R is R. What you do to one side, you have to do the other. So 4.5 divided by 3. 3 goes into 4 once, with 1 left over. 3 goes into 15.5, so that's 15. So I get R equals 1.5. 1.5 times 100 is 150. So R equals 150%. Okay, so quick review. To go from the original to figure A, it was a 50% scale factor. To go from the original to B, it was 150% scale factor. So think about it. 50% means that the scale drawing is a reduction. 150% means that the scale drawing is an enlargement. Okay? So hopefully you guys are seeing what we're working towards. We're still using the percents to figure out the change, but we're taking it to another place. Okay, last question, really quick, and I know this is kind of a funny question, but how would we stack these to make a snowman? That's what I want you to think about, and that's what we're going to talk about when we get into class tomorrow. Going back to our goal, today we will make scale drawings with a scale factor that is a percent. We did that. Ta-da! All of this work shows us. Okay. The question, can you have two different scale factors in the same drawing? Did we have two different scale factors in our same drawing? Remember, we were building a snowman. Did we have two different scale factors? The answer is yes. Okay. All right, so we're looking at how we would put those little shapes together to make the scale drawing of the snowman. And that's it, my dears. We'll practice it some more with some problems in class. See you then. Bye.